Everyone, welcome back to another video. This video is kind of a continuation from yesterday's video where I discussed two questions regarding redox. And in this video, I'm going to discuss two more questions that were sent to me by a subscriber. And these questions are arguably more difficult than the previous two questions. And mainly that's because you have some numbers involved in this. And when it comes to numbers, I see most students starting to freak out, and including myself, I also used to do this. Actually, I still do this. But really, what you have to realize is these questions are less to do with redox and more to do with stoichiometry. So let's take a look at this question. Let's see how we would go about solving this, and hopefully by the end of the video, you're more comfortable solving these types of questions. So in this question, we have, if X grams of silver are deposited in cell 1, what volume of oxygen in dm cubed at STP, so STP is standard temperature and pressure, is given off in cell 2? So really what we need to calculate is the volume of oxygen that is given off in cell 2 at STP. So they're not, because it's a paper one, you don't have access to a calculator. So naturally, they're not going to ask you to give, they're not going to ask you for a particular number, because doing such a calculation without a calculator is going to be pretty hard. So really all you have to do is formulate an equation which would give you the answer. Now, the first key part, or the key part to look at in this question, is what volume of oxygen in dm cubed at STP. So generally, how would you calculate the volume of oxygen in dm cubed at STP? Well, the formula for that is the moles of oxygen times 22.7. And this is to calculate the volume of any gas at STP. You multiply the number of moles by 22.7. Now remember, you can't do this for a gas which is not at STP. You can only do this for a gas which is at STP. So it's pretty simple when a gas is at STP. However, often in experiments this is not the case. But anyways, so this is the formula to sort of calculate the volume of oxygen in this question. Okay. Right. So here we have the volume of O2. So we sort of have a base. We know that these four options over here, they've given us four different equations. We know we've got one part, right? We've got the 22.7. Okay, we've got the 22.7, right? Now all we need is the number of moles of oxygen. So how do we calculate the number of moles of oxygen? Well, for that, we have to do a little something called working backwards. So if you look at the cell over here, if you look at the cell, they've told you that X grams of silver is deposited in cell 1. If X grams of silver is deposited, that automatically tells us that we have some silver being formed. And that means that silver is being reduced. So silver is the one which is taking in electrons in this reaction. Because if you look at cell 1, your solution is silver nitrate, right? Really, in order for silver to be deposited in cell 1, silver has to go, or the equation is going to look something like this, where Ag plus combines with an electron, to give you some silver, right? And this is going to be solid. So hopefully you can see that. Hopefully you understand that in order for silver to be formed or to be deposited, we are going to need silver to become, or we need Ag plus to get reduced. We need it to take an electron and form Ag. Now, in order for silver to be reduced, we're going to need something else to be oxidized. And the something else that's going to be oxidized, you should have a clue when they are asking for the volume of oxygen. The clue lies there. When they're asking for the volume of oxygen, that basically means that what's getting oxidized on the other end is water. So water is getting oxidized. So we have 2H2O. It's going to get oxidized. Oxidation is loss of electrons. So it's going to, this is sort of what the equation looks like. And we have some oxygen gas. right? So this is the equation for the oxidation of water. This is the equation. This over here is the equation for the reduction of silver. I'm just going to put a little, really quick, I'm going to put just these tags over here so that we know. Reduction, oxidation. Okay. So this is our two equations. These are the equations of what's happening in both of these cells, right? Now, how do you calculate the moles of oxygen, right? How do you calculate these moles of oxygen? Well, what we can do over here is we can combine these two equations to get one big final equation, right? We have these two half equations, right? We have the reduction equation, we have the oxidation equation. So we can combine these two equations and we can form one big equation. And in order to do that, obviously, the first thing you need to do is you need to balance the electrons, because over here you have one electron, over here you have four electrons. So you need to first multiply this side, or the reduction equation, by 4, just so that we have balanced number of electrons in both reduction and oxidation. So if you multiply that by 4, it becomes 4 Ag plus 4 E minus gives us 4 Ag. Now that the electrons are balanced, you can sort of cancel them out on both sides, because remember, in our final equation, in that big equation that we're going to make, we cannot show electrons. That doesn't work, right? You have never seen a chemical equation where we talk about, or where electrons is a species which is written down, right? We never write down the electrons that are being exchanged in a reaction. We only write them down in half equations. That's why they're called half equations, right? In order to make a full equation, you have to sort of cancel out the electrons and you just write down everything else, if that makes sense. So now we can cancel out the electrons and our equation ends up looking like this. We have 2H2O. You just combine, to make the big equation, you just combine everything on the left-hand side and you combine everything on the right-hand side. So you combine the reactants from both the reduction and the oxidation half equations, and you combine the products from both the reduction and the oxidation half equation. So we get 2H2O plus 4 Ag plus gives us 4H plus O2 plus 4Ag. I'm sorry, I've kind of gone out of space here, but hopefully you understand what I've done. Wait, let me condense this a bit because I don't want any confusions. So 4H plus O2 plus 4Ag. There we go. Okay, so this is our final big equation, right? This is our final big equation. Now they've told us something else in the question. They've told us that you have X grams of silver deposited in cell 1. So you have X grams of silver, right? You have X grams, you have X grams of silver which are deposited in cell 1. So this is our silver, right? This is our product that's been deposited. If we have X grams of silver, we're going to have, if you have X grams of silver, we can find out the number of moles of X grams of silver, right? We can find out, so they've given us the molar mass of silver, which is 108. So if we divide X divided by 108, we get the number of moles of silver that have been deposited. So X divided by 108, over here they've given us the molar mass. That should be a big clue. If they've given you the molar mass, they're probably going to need you to calculate, or a part of your equation has to do with calculating the number of moles of silver. So we have X divided by 108. Now, what did I tell you earlier? Our equation, we need to find out the number of moles of O2. We know the number of moles of silver that have been formed. Now, the next part is really quite simple, right? It's a stoichiometry. The ratio of the number of moles of silver formed to the number of moles of oxygen is, for every 1 mole of O2, you get 4 moles of silver, right? That is the ratio. It's 1 to 4. So if you have X divided by 108 moles of silver, your number of moles of oxygen is going to be X divided by 108 times 1 over 4, right? Because it's 1 to 4. So if you have, for example, 8 moles of silver, you're going to have 8 divided by 4 moles of oxygen. If you have 10, it's going to be 10 divided by 4. So whatever moles of silver you have formed, you're going to get that divided by 4 in the moles of oxygen, if that makes sense. Hopefully that makes sense. It's all about the ratio, the stoichiometric ratio over here, looking at that. So X over 108, this is the moles of silver. In order to get from the moles of silver to the moles of oxygen, we multiply by 1 over 4 because that is the ratio that we have obtained in our final big equation, right? We can see over here, I've not written the 1. We don't typically write the 1. Oops. We don't typically write the 1, but this 1 exists over here, right? We don't typically write it, but it exists. So hopefully you can see how I have got the moles of oxygen. So X over 108 times 1 over 4 is going to give us the moles of oxygen. So now if we go back up to our main equation over here, this equation, we can substitute our value that we just got. We can substitute our value, and what we get is X over 108 times 1 over 4 times 22.7 is going to give us the volume of oxygen. And this part is a number of moles of oxygen. And I hope that you have understood how I got to this. Number of moles of silver is X over 108. Since the ratio of silver to oxygen is 4 to 1, we divide the number of moles of silver by 4 to get the number of moles of oxygen. And we multiply that by 22.7 to get the volume of oxygen. Which answer is that? That is answer number A. So that is our correct answer. So that is it for this question. It's question number A. It's answer number A. Hopefully you guys have understood that. I'm going to move on to the next question. It's pretty similar to this question, and that's why I would encourage you to pause the video and just have a go at it by yourself. And then I will proceed to give you the answer. And oops, looks like you've already probably seen the mark scheme, but please give it a go by yourself and see if you get the correct answer. Okay, I trust that you have paused the video and attempted this question by yourself. I'm going to go ahead with it. It's really the same concept as the previous question. It has some math in it, so don't get scared. It's very simple, and let's kind of go through this. So the question states that the two electrolytic cells are connected in series, and the same current passes through each cell. The first cell contains silver electrodes in silver nitrate solution. The second cell contains copper electrodes in copper sulfate solution. In one experiment, 1 gram of silver is deposited in the first cell. What mass of copper in grams is deposited in the second cell? Okay, so really the important thing over here to understand, or the difference between this question and this question, is that in this we have electrolytic cells, whereas over here we have voltaic cells. So electrolytic cells are different from voltaic cells. I'm sure you all know the differences between both of them. And if you don't know, you should check out one of my previous videos where I discuss both of them in depth. But that is one primary difference, or that is one difference between these two questions. So if you have an electrolytic cell, that really means that you have a battery or an electricity source outside the cell, which is supplying the energy to break apart the ions or the molecules in the solution so that they deposit on your electrodes. That's kind of what you're doing in electrolytic cells, right? You're providing an outside energy, whereas in voltaic cells, there is no outside energy. The energy is provided by the oxidation of one cell, and that allows the solution in the other cell to get reduced and deposit on the electrons. Hopefully that makes sense. So that was a brief rundown of electrolytic versus voltaic cells. But in this case, in this scenario, we're going to have reduction occurring at both ends. We're not going to have oxidation. No, both cells, right? We have two cells over here. Both cells are going to have reduction happening in them. And we can have this reduction through the outside current, which is passing through both of these cells. And they have mentioned that the current that is passing through both of these cells is the same. So it looks something like this. You can kind of imagine you have like a battery over here. You have a battery. It's connected to one cell. This is a very bad drawing of a cell. It's connected to one cell, and then it's also connected to another cell. And both of these cells have different species in them. So this one has copper 2 sulfate, and this one has silver nitrate. Hopefully that makes sense. Okay. So they've told you that 1 gram of silver is deposited in the first cell. What mass of copper in grams is deposited in the second cell? Now, again, the process is the same. Write down the half equations for the reaction that is happening. They've told you that silver is being deposited. Now, what is the sort of the half equation for silver? Well, we know that it's Ag plus. It's going to gain an electron, and it's going to form Ag. So this is our first equation for silver. Then they've told us that copper is also being deposited. So what is the equation? What is the half equation for copper? Well, it's copper 2, so it's going to be Cu2 plus 2E minus gives us Cu. That is the second equation. Now, we need to cancel out the electrons first if we want to make a final big equation. So we multiply this by 2 to make sure the electrons are the same in both equations. So it becomes 2 Ag plus 2 E minus gives us 2 Ag. And now our final equation will be Cu2 plus 2 Ag plus gives us Cu plus 2Ag. Now, I'm gonna give you a little disclaimer. This equation by no means is correct. I mean that I have only written this equation for the sake of explanation, because if you look at this equation, this is not a redox reaction equation, because in this case, both species are getting reduced, and that doesn't work for a redox equation. In a redox equation, you have something getting reduced and something getting oxidized. In this case, both things are getting reduced. And the reason why both of these species are able to get reduced is because we have this outside battery, which is providing the electrons, which allows them to be reduced, if that makes sense. So this equation is only for explanation purposes. I do not claim that this is a correct equation. I'm only using this for an explanation purpose, right? Hopefully that's made sense. Hopefully you do not take this as something that I have done correctly. This is something that I'm just using for an explanation. Okay. So they've asked you to calculate the mass of copper in grams, which is deposited in the second cell. Now, how do you calculate the mass of copper? Well, we've learned this formula time and time again. We've learned this formula. We know number of moles is equal to mass in grams over molar mass. Now we want to find out mass in grams. So if we just rearrange this equation, mass in grams is equal to number of moles times molar mass. So we know the molar mass of copper. They've actually given it to us in the question. Well, actually, they haven't given it to us in the question, but you can see that in your answer option, 63.55, 63.55, that is an indication that you need to use this particular formula over here. If you see this 63.55, that is the molar mass of copper, and that is a very strong indication that you need to use this N is equal to M over capital M equation, right? So molar mass is 63.55. Now, how do we calculate the moles of N? How do we calculate the moles of copper? This is moles of copper. How do we calculate this? How do we do that? Now they've told you that you have 1 gram of silver being formed. So we can use the number of moles of silver that is formed to calculate the number of moles of copper that is being formed. Because remember, we've made this big equation for that purpose, so that we get the molar ratios, right? This big equation is going to help us with that. This is the reason why I put this equation down. It's going to help us to determine the molar ratio between silver and copper. So we have 1 gram of silver. So how many moles of silver do we have? So number of moles of silver is equal to 1 divided by 108, right? That is the number of moles of silver. Now we see that the ratio of silver to copper is 2:1. So for every 2 moles of silver, you're only going to form 1 mole of copper, or half of what you form. So if you have 10 moles of silver, you're going to form 5 moles of copper. If you have 4 moles of silver, you're going to form 2 moles of copper. If you have 3 moles of silver, you're going to form 1.5 moles of copper, right? So on and so forth. So if you have these many moles of silver, you're going to form 1 over 108 times 1 over half, or sorry, half. That is the number of moles of copper. I hope you've understood that. So we found out the number of moles of copper. Now, all we need to do is substitute this back into our equation. Let me just erase this. Oops. This equation over here, this big equation over here, where mass in grams is equal to molar mass times number of moles. We know that molar mass is equal to 63.55, and we know that the number of moles is half times 1 over 108. And this is the number of moles of copper, and this is the molar mass of copper. And again, just to reiterate, how did we get the number of moles of copper? We got it using this big equation. We got it using the stoichiometric ratios. So for every 2 moles of silver formed, we're going to get 1 mole of copper. So the ratio is 2:1. So if you have 1 over 108, 1 over 108 moles of copper, whatever this number is when you divide it, we're going to get half of this in the moles of copper. So we multiplied by 1 over half, or we multiplied by half. And that is our answer. Now, which one fits our answer? Well, that is option number C. Over here, they've just put the 63.55 on top of the 2. So it looks something like this. If we condense it, oops, if we condense this. Right, so now this looks like our answer. Hopefully that's made sense. Thank you so much for watching. That is it for this video. I will start taking on questions regarding HNMR and just the topic 11 and 21 in general. I think there is some confusion regarding that. I'm going to take up some questions on that topic. And if you would like to do some more revision on that topic, in the meanwhile, I have uploaded many videos on HNMR and IR spectrum and how to use the data in your data booklet to determine the structure of molecules. I believe this was one of my earliest videos on this channel. So if you really scroll down, you can find a video on that. So anyways, I will take up another question on that in the next video. Thank you so much for watching. I really appreciate all the support that you guys have been giving me. It means a lot. And I will see you in another video with another question. Goodbye and take care of yourselves.